Okay, guys, so this is the review for our final exam this year. So as I mentioned in class, our review is going to be focused on only SAT questions. And obviously the reason for that is because your final will be only SAT questions. Okay, so I'm going to kind of walk you through all of these questions. And hopefully, if you have any questions or concerns, you can let me know. All right, here we go. Now, I broke these questions down by no calculator and calculator, and that's how the exam will be. So make sure that you're prepared that some of these questions you will not be able to use a calculator. All right, so let's start with the first one. It says, which of the following represents all the possible values of x that satisfy the equation above? So this is a proportion, and the way you want to solve this is we're going to multiply across, all right? And then take those cross products and set them equal to each other. So x times 2 is 2x, and then 2x times x minus 3 is 2x squared minus 6x. Now we've created a quadratic equation. The way I want you to approach this is to move that 2x to the other side with subtraction. So negative 6x minus 2x gives negative 8x. All right? Now, I don't see a third term here, so it's not a trinomial. It's still a binomial. So I'm going to factor out what they have in common, which is 2x. And that leaves me x minus 4. All right, so whatever makes these factors 0 are my solutions. So I have x equals 0 and x equals positive 4. All right, now, always before you answer the question, go back and look. Do these have any issues? Like if I plug in 0, do I make a 0 in the denominator? Same with 4, and I do not, right? Neither of these are extraneous. They are both solutions. So 0 and 4 is the answer. Okay, now number 2. Now, because of the pandemic, we weren't able to work on anything in terms of conic sections where we would have talked about circles, right? So this equation that we're going to need for the equation of a circle is x minus h squared plus y minus k squared equals r squared. Now let me mention what the letters mean. So the x and y you're never going to plug into when you write it. You can plug into them to find other things, but in terms of writing your equation, the x and y should stay x and y, as you notice in all the answer choices. H and k are from the center. All right, so this is actually h and this is k. And the big thing that students will mess up when they do this is that the formula uses subtraction. So when you use these numbers, you need to think opposite. So it's actually going to be x minus 5 and y minus 7. So I can cross out b and d because they forgot to think opposite. And then for the radius, that's r squared. So again, it's equal to the radius squared. So the radius is 2, and 2 squared is 4. So A is the answer. So even though we did not get a chance to really work on conic sections this year, just to let you know that circles will be a part of it. So there's another question later on in the review. We'll talk more about this again. Okay, number 3. What are the values of x that satisfy the given equation? So we have a radical that I need to get rid of. So I'm going to square both sides. And when I square both sides, I get 4x equals, and this is a binomial squared. So don't forget to expand it fully, x squared minus 6x plus 9. So many students will forget that middle term minus 6x. Another quadratic trinomial. So I'm going to set it equal to 0. All right, this 4x is going to move over with subtraction. So negative 6x and negative 4x is negative 10x. All right, we're going to factor this quadratic trinomial. So I'm thinking factors of 9 that add to negative 10. So that's going to be negative 9 and negative 1. So my answers are 9 and 1. Now again, before you pick your answer choice here, you have to plug into the original. So I'll go ahead and erase. Plug into the original to see if these both work. If I plug in 9, I get the square root of 36 equals 9 minus 3, which is 6, so that's right. But if I plug in 1, I get the square root of 4, which is 2, equals 1 minus 3, which is actually negative 2, and 2 does not equal negative 2. So 1 is what we call an extraneous solution. So only 9 is going to make this true. Okay, number 4. Similar to the first one, we have a proportion. So we're going to multiply across, so diagonally for our cross products. So I have 2 times y equals 4 times a minus 1, which is 4a minus 4. Now it wants me to solve for y in terms of a. Now I've almost got y by itself, right? Solving for y means isolating it. So I just have to divide both sides by 2. And if I divide both sides by 2, I'll get y equals 2a minus 2, which is a. Okay, number 5. Now, number 5 has this expression, 20 plus 0.1 times t, and it says this expression represents the amount in dollars that a phone company charges per month for their texting service, where t represents the number of text messages the customer sends. But this problem is actually asking about the 20. All right, so this question is asking about what is called the y-intercept. So when t is 0, so if I send 0 text messages, I still owe $20. So I'm looking for something in my answer choices that says no matter how many text messages I send, I still have to pay $20. So C makes sense. The customer must pay $20 per month in addition to a charge for each text message sent. Okay, now number 6 is some factoring, and you could go ahead right now and do our factors of a times c that add to b, but I notice in the numerator that I can actually factor out a 3. All right, so 15, 27, and 6 all have a 3 in common, so I can do 5x squared minus 9x minus 2. So ultimately, I'm going to do factors of a times c that add to b for this quadratic trinomial. Okay, where a is 5, b is negative 9, and c is negative 2. So a times c would be 5 times negative 2, which is negative 10, and b is negative 9. So I'm looking for factors of negative 10 that add to negative 9. All right, so that's going to be negative 10 and positive 1. All right, now again, because my a is not 1, right, my a is 5 once I factored. When I do this, I have to factor 5x squared minus 10x plus 1x minus 2, and I need to factor by grouping. All right, this is something that we talked about in the past, and it's going to happen every year you take math, okay, until you're finally done. So we have 5x times x minus 2, take out a positive 1, and you're left with x minus 2. So this becomes 5x plus 1 times x minus 2. Don't forget, we did have a 3 right at the beginning of this that we factored out, so bring that down, and your denominator was x minus 2. You should notice now that we're crossing out x minus 2's, so what's remaining is going to be our answer, which is 3 times 5x plus 1, or letter B. Okay? All right, number 7. We have a function, f of x is defined as x plus 4, and then another function that's f of 2x. So the way you want to do this is you're going to plug in that 2x where it says x, all right, which is 2x plus 4. So they're the same y-intercept, so it's not going to be a or b, right? 4 is still the same. All right, but our slope is 2 instead of our slope previously, which was positive 1 in front of that x. So a slope of 2 is greater than a slope of 1. So our slope is greater than that of f of x. All right, let's go to number 8. It says, which of the following values of x is not a solution to this equation? Again, I'm going to square both sides, and I'm going to get x squared equals x squared, right? This is a true statement. So that means every number will work. Every number will work. But obviously, not every number will work. Otherwise, it would not say which of these will not work. So when I practice, or when I plug these in to the original, right? If I plug in negative 4, I get negative 4 squared, which is 16. And the square root of 16 is 4. But if you look, right, it says it's equal to x, which in this case, x is negative 4. So 4 does not equal negative 4. So A is going to be one of those extraneous solutions. All right, all the other ones will work. No, I shouldn't have crossed it out. Sorry. That meant that's the answer. There we go. Okay, number 9. It says, near the end of a U.S. cable news show, the host asked those viewers to respond in a poll. All right, so they're answering a question, And it says, which of the following best explains why the results are unlikely to represent the sentiments of the population of the United States? So we're talking about after a cable television show, right? The host is saying, hey, go online and go to our website and answer this poll, all right? Now they're trying to trick you with A, saying the percentages don't have to 100. That's fine. They don't have to, right? There could have been another option besides yes or no, maybe undecided or something else. Right? Then it's saying there were not 50% yes and 50% no. Again, this is like their sentiment, right? So it's probably not going to be 50-50. And then the show did not allow viewers enough time. It doesn't really mention a whole lot besides like they say, hey, go and vote on our poll. So not real sure what that's trying to do. So really the only answer that makes any sense is B, all right? Because ultimately, if you're going to talk about survey results representing a population, then the sample needs to be representative of that population. And people that are watching this cable news show are probably not necessarily a good representation of all Americans. So that's why the answer is B. Okay, number 10. The way we've talked about solving exponential equations is to first try to write them with the same base. So I'm going to write 5x plus 4, just copy that down, but I'm going to rewrite 25 as 5 squared. And when I do that, I get a power to a power, which is going to be 2x plus 6. You multiply the 2 times the x and the 3. Don't forget the 3. So now that the bases are the same, I'm going to set my exponents equal to each other. All right, so I'm going to write x plus 4 equals 2x plus 6. All right, solving this, moving the x over gives me x. Moving the 6 over with subtraction gives me 4 minus 6, which is negative 2. Plug it in and check, and you see that it is true. Okay, number 11. We have Jake has a bag of popcorn at the movie theater. It says he eats half of the popcorn during the first 15 minutes of the previews. That's exactly what I would do, Jake. And then after that, like, ooh, maybe ate too much too fast, so they stop eating, or Jake stops eating for the next half hour. And then he gradually eats the popcorn until he spills it all and there's no more left. Okay, so again, we're looking at amount of popcorn in the bag. So I'm looking at a decrease first, right, because he's eating it first, so not D. Then I'm looking for constant after that. So I have that in all of them. And then the rate should slowly go down, right? This one doesn't. And then at the end, it should go to 0 pretty much immediately. So this one goes to 0 pretty much immediately because he spills it. Okay. Number 12. All right, we have a researcher who believes that the employee job satisfaction varies greatly from their 50 stores throughout a state. Which of the following methods is most appropriate to estimate the proportion of all employees of the company who are satisfied with their job? So here's the thing, guys. If it says that the researcher thinks that employee job satisfaction varies greatly from store to store, you really need to do your best to try to get as much representation from every store. So if it says, selecting one of the stores and then surveying each employee at that store, I mean, that's very convenient because you only have to go to one place in the state. But again, I'm only asking people at one store. So if we're saying that people at all the stores feel differently about their job, it's not really going to be a good representation. All right. Surveying the highest paid and the lowest paid, well, I mean, I can probably tell you who's going to like their job, who's not going to like their job. And then creating a website on which employees express their opinions using the first 50 responses. Well, you can probably imagine the first 50 people that are going to give their feedback are probably people who really love their job or really hate their job. So it's not really going to be the sentiment or a representation of the sentiment for everyone. So the way to do this is to go to every store and select 10 employees from each store at random. Okay? That's how you get a random sample from each store. Okay, let's go to 13. Where's 13? There it is. Okay, we have a researcher surveyed a random sample of students from a large university about how often they see movies. The researcher estimates 23% of students in the population saw a movie at least once per month. The margin of error is 4%. Now, a quick little conversation about margin of error. That means the researcher thinks it's 23%, right? They think that 23% of these students are seeing a movie at least once per month. But they're not, they're not exactly sure it's going to be 23%. So it's plus or minus the margin of error of 4%. So that means if we subtract, it could be down as low as 19%, or if we add, it could be as high as 27%. So we still think it's 23%, but we're willing to make concessions by saying we don't know if it's exactly 23, we think it is, but it could be a little higher, maybe all the way up to 27%, or it could be a little lower, all the way down to 19%. So the only thing that's really saying that about this conclusion is letter D, that it's plausible that the percentage of students who see a movie at least once per month is between 19 and 27%. All right, so that's margin of error. Let's go to 14. All right, we have two lists of numbers. Which of the following is true comparing these lists? Let's talk about the mean and standard deviation. Let's talk about the mean first, right? The mean is you add all the numbers up and divide by the total number of data values. So in the first one, we have 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? So that's going to be 21. And in the next one, we have 2 plus 3 plus 3 plus 4 plus 4 plus 5, right? This is calculator, so if you want to use a calculator, you can, right? But ultimately, you should see it's also 21. So 21 divided by 6 gives you the same mean. So the means are the same. So not going to be C or D. Now, in terms of standard deviation, the way that I describe standard deviation for you guys is ultimately it's the average distance of your data values to the mean. All right, so I'll go ahead and show you the mean real quick. I'll use Desmos. All right. So I'm going to take 21 and divide by 6, right, which gives me 3.5. All right, so the mean for both of these, all right, is 3.5. So to calculate the standard deviation, right, we're not going to actually calculate it, but we can imagine we are. And so we're looking at how far away our data values are from 3.5. Well, what I notice about the difference between list A and list B is that list A goes all the way down to 1 and up to 6. All right, but list B only goes down to 2 and only goes up to 5. So in list A, you have data values that are farther away from the average, right, from the mean. So if you have data values that are farther away than the other data sets, that means the standard deviation for list A will be more than the standard deviation for list B. Now, it's not actually asking for that much depth, right, but ultimately that's what my brain and your brain needs to understand. So the means are the same, but the standard deviations are different. If I had to go farther, I would say the standard deviation for list A will be greater than the standard deviation for list B. Okay, number 15. We have in 2015, so we have 2015, city X, city Y have the same population. Okay, so the same population. In 2010, it says city X was 120,000. Okay, and we're trying to find the population for city Y in 2010. Now it gives us some more information. It says from 2010 to 2015, city X population, so 120,000, increased by 20%. So this increased by 20%. Okay, while 120,000 times 20%, right, is going to give you 24,000. I can calculate that for you with Desmos. What my brain usually does to do this mentally is take 10% of 120,000, which is going to be 12,000, and then you double it. But we don't have to do it mentally. We have a calculator. So 120,000, I don't think I need it. There we go. Times 0.2. There you go, 24,000. Now that's not the new population. You have to add that back plus 24,000. So the new population for city X in 2015 is 144,000. All right, now here's the deal. It says in 2015 they have the same amount. So city Y is 144,000 in 2015. But it says that city Y decreased from 2010 to 2015 by 10%. So this number that I'm solving for actually needs to be more than 144,000. So that eliminates A and B. All right, so I'm asking myself, is it going to be 160,000 or 240,000 to get to 144,000 when you decrease by 10%? Okay, Now you can do this using the answer choices, or you can mathematically do it, right? Ultimately, we have some number times 0.9. I got that from doing decreasing by 10% is 1 minus 10%. I guess I can show that work. Let's show it. So it'll be 1 minus 0.1, which is 0.9, equals 144,000. So to get our answer, we divide both sides by 0.9. So essentially, I'm looking for 144,000 divided by 0.9. Let's see what I get. All right, so 144,000 divided by 0.9 is 160,000. All right, so again, you could have done this a different way and just tried both numbers since you only have two answer choices that would fit. So the answer is 160,000. Okay, number 16, still using calculators if we need to. The table above shows the results of a survey in which tablet users were asked how often they would watch video ads in order to access content for free. Based on the table, which of the following is closest to the probability that a tablet user answered always? And then this is important. This is called a conditional probability because it says given that the tablet user did not answer never. So how you write this is you write probability that they answered always, and then you put this bar for given that they did not answer never. So not never. Now, how you do this for a formula is your denominator is that condition. So it says given that the tablet user did not answer never. So in the denominator, I'm going to put the percentages of those that answered not never. All right, so that's these three here. So I have 0.243 plus 0.135 plus 0.309. I change them to decimals. And in the numerator is where you put what you're looking for. You're looking for always, all right? And always is just 0.309. All right, so if I type this into Desmos, I'll have my answer for number 16. All right, so I have 0.309. Let's delete some of this stuff. All right, so I have 0.309 divided by 0.243 plus 135, and then plus 0.309. So my answer is 0.44978, which looks like it rounds to 45%, or 0.45. Let's see which our answer is. There we go, C, 45%. Okay, number 17. The maximum value of a data set consisting of 25 integers is 84, so our max is 84. A new data set consisting of 26 integers is created by adding just one extra number to that original data set, and they're adding 96. So you have a bunch of numbers, right? You have 25, that's a ton of numbers, and your highest one is 84. Then they do the same thing, but the new one has this 96. Which of the following measures must be 12 greater for the new data set than for the original? So you probably can imagine that the mean is going to go up, right? If we add a number that's bigger than our previous max, it's going to go up. It's not going to go up 12 though, because remember, you're going to be dividing that new sum divided by 26 as opposed to 25. So it's going to go up, but it's not going to go up by exactly 12. The median. Now the median is that middle number. So the median is resistant to those possible outliers. Now we're not really going to talk about outliers, but really the median, because it's the middle number, doesn't really care how far a number is to the right? 84, 96, not really going to care. Technically it could change, but if it's going to change, which technically it might not change, but if it's going to change, it's not going to change by 12. It might go up a little bit, but it's not going to change by exactly 12. Again, the standard deviation, we talked about this in a previous problem, is the average deviation of your data values to the mean. So if the mean goes up and you have a data value 96 that's farther away, the standard deviation will most likely go up as well. But again, not by 12. The only one that will guarantee will go up by 12 is the range. Okay, the range is the highest minus the lowest. So if you're not changing the lowest, but the highest number you're changing by adding 12 units, then your new range must be 12 units more. Okay, let's go to 18. All right, 18 gives us this scatter plot with a line of best fit. And it says which of these could be the equation of the line of best fit. So line of best fit, you're just looking for a slope and a y-intercept, right? Slope-intercept form. So when I'm looking at this, if I look at these points here that are on the line, it looks like I'm just going up 10 and over 20. So up 10 and over 20 would be a slope of 10/20ths, which is going to be 1/2. And the only answer I see that has a positive 1/2 slope is B. Number 19. We have a formula that's used to approximate the height h in inches of an adult male based on the length in inches of the femur. What is the meaning of the 1.88? So that 1.88 is the slope. And I told you guys in general terms, the slope of a line means that if you increase your x value by 1 unit, then the y value will go up or down by the amount of your slope. So in this case, if I have an adult male that has a femur that's 1 inch longer, then I expect the height of that man to go up by 1.88 inches. So I'm looking at my answer choices for that answer. All right, and it looks like it's D, the approximate increase in a man's height in inches for each 1 inch increase in his femur length. Okay? All right, still calculator. Number 20. Given functions f and g, what is f of 0 and g of 0? Well, let's find f of 0. We're plugging in 0 for x. So that's going to be 0 times 2 is 0 plus 1 is 1. And g of 0 is 4 times 0 minus 4, which is going to be negative 4. So when you multiply those together, you get negative 4. Boom, done. Nice work. Internet usage at Washington High School. Here we go. Administrators at Washington High School randomly surveyed 20 students about their internet use during class. Which of these statements is false? Now, the mode is the number that occurs the most often. What I would tell students about this problem, I'm not going to actually do all of them, but the idea is that you have one student said 1 hour. You had 7 students said 2 hours, so you'd have to have like 7 twos here. Let's see, 1, 2, 3, 4, 5, 6, 7, boom. Then you'd have 8 threes. Again, I'm doing this, but I would never do this to answer this question. Just showing you what this histogram means. 1, 2, 3, 4, 5, 6, 7, 8. Wow, that was lucky. And then 4 4-hours. 4 students at 4. So essentially, that's the data, right? We have a graphical display of that data, but that's the data if they just gave it to you, in a table or however else. All right. So the mode is the one that occurs the most often because that bar, right, in this histogram is the highest, right, at 8. That is true, right? That is true. So it's not going to be A because the mode is 3. That's the one that occurs the most often. The mean of this data set is 2.75. Again, you would add all those numbers up. All right, what I like to do is to use multiplication help. So you have 1 times 1 plus 7 twos plus 8 threes plus 4 fours. All right, so that's going to be 1 plus 14 is 15. 15 plus 24 is 39. 39 plus 16 is 55. So my sum is 55 divided by 20 students. So we can go to Desmos to see what that is, to see if the mean is 2.75. So I'm looking for 55 divided by 20, which is 2.75. So I know that one's true as well. So that's not the answer because it's asking for a statement that is false. That is true. Exactly 60% of the students surveyed use the internet 3 or 4 hours per day. Well, let's see how many students use the internet 3 or 4 hours per day. We have 8, say 3 hours, and 4, say 4 hours. So that's 8 plus 4 is 12, and 12 out of 20 is 60%. So again, that's true. So I know the answer has to be D. Let me show you why. Right, I did write all the numbers so you could find the median that way, but the way to do this is to take your total number of students, which is 20. All right, 20 divided by 2 is 10. Because this is an even number, right, 20 is even, you're actually looking at the 10th and the 11th number in your data set, and that will be the median. All right, it'll be the average of those two. Now, what happens with this is we have, 1 here, 7 here, right? So I'll do it like this. 1 plus 7 is 8. I have not made it to the 10th and the 11th, but this is 8 here. So when I add that to my already having 8, 8 plus 8 is 16. So my 10th and my 11th data sets, my data values, are in that bin of the histogram, which is 3. So the average of 3 and 3, right? So this is 3 and 3. The average of that is 3. So the median is 3. So that means the median is actually bigger than the mean of 2.75, right? But this statement says the median is smaller than the mean, which is not true. That is false. Awesome. All right, that's 21. 22. Every year, the population of these rabbits doubles in a certain country. If there were 50 rabbits in 2017, how many would there be in 2021? So 2018, it doubles 100. 2019, it doubles 200. 2020, it doubles 400. So 2021, my answer is 800. Boom. That's exponential growth. 23. Which of the following equations could approximate the line of best fit for the scatter plot above? So first thing I notice, if I were to draw a line, I'll use any color here, it doesn't matter, right? You're just trying to find a line that goes kind of in between them. So something like this. Sure. All right. That's a positive slope. So not going to be A or B. So I'm looking for a positive slope here. And then in terms of the y-intercept, I have options here. I have -4 and -8. I didn't do a great job of this, but ultimately, if I look, this is -2. Down here would probably be around -4. -8 would be way farther down. All right, so I'm going to go with -4 for the y-intercept. Okay, let's keep going. 24. All right, we have fire ant colonies in Greenville, and it gives us the table here, all right? And what I noticed when I subtracted, right, each of these values, I'll show you the first one, right? You can trust me that I did it for all of them. But when I subtract, just to see the difference in the years, right, 48, 545, so 48, 545 minus 46, 164. You get 2,381. Now what happens is if you do that for the next two of those, right, these next differences, you get the same thing. So if you have a constant change in your values, that means you have a linear slope, all right? You have a line, all right, a linear function. All right, so when I look at these answer choices, I know it's not A, right, because A is exponential, right, it's a curve. So B, C, and D all have lines. Now D is going down, but if you look at my growth, it's actually going up from 92 to 95. So it's not going to go down. So the question is B or C. What I notice is the difference between them is the answer choice in letter B goes through the origin of 0, right? But we're not starting at 0 in 1992, right? We're starting above that, so we have to pick C. Okay, number 25. Which of the following is equivalent to this expression? So I need an LCD, right? An LCD for X, Y, and XY is actually XY. So the first one, use a different color here, needs to be multiplied by Y over Y. This middle one needs X over X, and the last one needs nothing. All right, so you have 2Y plus 3X plus 5 all over XY. So you're looking for that answer choice, which is B. All right, 26. Now, this problem really frustrated me. You'll see why in a second. As a stats teacher, whenever I have data like this in a two-way table or a contingency table, which is what this is called, super frustrating to see them not give me the actual counts. Instead, it's giving me percentages in the actual table. That is ridiculous. I've never seen that before. If you have the percentages, that means you have the counts to calculate them. So anyway, fine. SAT, you win. So we have 1,500 people. So grand total, 1,500 people were selected at random from New York City and asked the question, do you think the streets are safe for pedestrians? Based on the results, which of the following statements are likely to be true? So of all people surveyed, so that's out of 1,500 people, approximately 39% think the streets are safe for pedestrians. So if this was a real problem in real life, they would already have given me numbers here, and I would take the total of those, and that would be my numerator. But they're going to make me work for it, which is super frustrating. So I'm going to plug into Desmos to find those actual numbers. So I need 10% of 589, which is 58.9, or 59. So I actually know that once already now. So that's 59. Plus 40% of 372. I'm going to use the calculator to help me with that one. 40% of 372. 40% of 372. So that's 149, right? We can't have 0.8 of a person. So 149 plus, I need 70% of 539. 70% of 539, which is 377. Again, just rounding here. If you didn't round, you'd still got the right answer. Okay, so if I add those together in the numerator and divide by 1,500, I'll get my answer, and I'm hoping that it's 39%. So we have 59, put those parentheses, plus 149 plus 377, all divided by 1,500, and you get, bing pot, 39%. All right, so thanks for making me do all that work, SAT. So 1 is true. No, Roman numeral 2, of all the people in New York City, again, 1,500, right? A greater proportion prefer to walk than bike. All right, so let's look. We look at the walking and biking. So out of 1,500, we had for walking, 589 out of 1,500. And for biking, we had 372. All right, so it looked like there's a greater proportion that choose to walk than bike. So also true. So the last one, of all people who prefer driving. So that would tell me that I'm just looking at the driving number, which is 539. 70% think the streets are safe for pedestrians. So I'm looking at just driving. So out of those 539, 70% think the streets are safe for pedestrians. That's true. That's in the table. It says it already, right? If they would give me a number, I would have used the number to find it, 70%. So also true. So all are true. Awesome. That's 26. Let's go to 27. Oh my gosh. 27 and 28 are using this information here, all right, about a botanist exposed 100 randomly selected buttercups to a new chemical, then released parasitic flies into the greenhouse. She then compared her sample with another 100 randomly selected buttercups that were not exposed to the new chemical. The results of her experiment are summarized above. All right, so we have an experiment here that's randomly assigning treatments. Okay, so the botanist reports her findings to a company that's interested in the chemical. Based on her experiment, which of the following statements is true? Since the buttercups were not split into groups, it looks like they were split into groups. We have 100 exposed to a new chemical and 100 that were not. So I don't know what that means. It's okay to split them into different groups, right? You have a control of not using the chemical. I mean, they're chosen at random. So I'm going to say that they conclude that the chemical is effective if they randomly assign treatments. That's a key thing about experiments. Guys, if they don't have something about randomly assigning treatments, well, then I am worried. All right, 28. According to the results of the table, if a buttercup were found to be resistant to flies after the experiment, so my denominator is resistant. So I'm looking at the total of 88 resistant buttercups. What is the probability that it was exposed to the new chemical? That's 78. So I'm looking for this answer. Oh, shoot, it's not there. But if I divide by 2, I get 39 over 44. Okay, let's go to 29. 29 says, if the equation y equals 3 times 5 to the x is represented by the dotted line, the dotted curve, and the equation y equals a times b to the x is represented by the solid curve, which of the following is true about a and b? Well, what I noticed about this is that I told you guys a long time ago with exponential functions, when you graph them, 0, 1 is on there. All right, but if you have a number in front, like this 3, you're going to plug in 0, get 1, but then you multiply by 3. So this point on the dotted line is actually 0, 3. So if my point on my solid line is above that, let's say 0 something else, right, 4, 5, 6, 7, that means my a value needs to be more than 3. So I'm looking for an a value more than 3. Now, if they're going to meet here at 115, all right, 1 comma 15, let's say I have 5 times, and I'll just use 3, right, to the first power, because 3 to the first power is 3, 3 times 5 is 15. That would tell me that my b value, my base, would need to be actually less than 5, because I'm using 3. So the answer choice that lines up with those is letter C. All right, number 30. We have a research assistant randomly selected 75 undergrad students from the list of all students enrolled in the psychology degree program at a university. She asked the students a question, then she found some data, and with a margin of error of 4.28. It says, which of the following samples will most likely result in a smaller margin of error? All right, smaller margin of error for the estimated mean time that students read per day. Now, I'm going to tell you this, guys. This is a topic that you really dive into in an intro statistics course, so it's almost pretty challenging for this to be on the SAT. But what I tell my students that I teach in our stats class here at the school is that if you want to essentially do everything the same, but decrease the margin of error, all right, so essentially be more confident in your results, then you must take a larger sample size. All right, so in this case, I'm looking for a larger sample than 75. So 40 is not bigger than 75. So 300 sounds good. That's larger. But you want to do everything the same. All right, and so when they did this originally, they took students that were from the psych program. So I don't want to all of a sudden start doing 300 students from all degree programs. I want to keep with that same thing they did in the original, which is select 300 students from the psych degree program. Okay, again, that's a really challenging concept, but ultimately the main takeaway is to reduce the margin of error, you must increase the sample size. Okay, here we go, number 31. We have the mean age of all male primates is 15 years. The mean age of all female primates is 19 years. Which of the following must be true about the average age for the combined group of male and female primates? Well, what they're trying to get you to think is that it's 17, because 15 and 19, what's in between 19 and 15 is 17. But there's no way I could possibly know that's going to be 17 without knowing how many males, how many females, what their actual ages are. All right? Again, it could be more than 17. It could be less than 17. I have no idea. What I do know is that if I'm looking at combining these and finding the mean of the group, I know it will be between 15 and 19. Okay, 32. This researcher wants to know if there's an association between exercise and sleep for 16-year-olds in the U.S., right? That's the population. All right? They obtained survey responses, and they found convincing evidence. So they found convincing evidence of a positive association between these two things. All right? Now, here's the thing. The answer choices are trying to get you to confuse correlation with causation. All right? So what I have my stat students write, correlation does not equal causation. The only way that you can prove a cause and effect relationship is to run an experiment. This is not an experiment. It says a sample, right? A random sample of 2,000 16-year-olds. So because it is a random sample, we cannot assume causation. We can say there's a correlation, and so I'm crossing out C and D. All right, so the question is, what is my answer? They look the same, but the population is from the U.S., so my conclusion can only be about those 16-year-olds in the U.S., not the world. Okay, 33. So these are where we're going to have to find the answer. Okay, no calculator to be used. So what is the greater of the two values of n that satisfy this equation above? This is a proportion. You put it over 1. So multiply cross products. So n squared plus 1 equals positive 26n minus, let's see, 13 times 8. 10 times 8 is 80. 8 times 3 is 24. So minus 104. All right, I have a quadratic equation. So move everything to one side to set it equal to 0. So minus 26n. And if I move that minus 104 over with addition, I get 105, which equals 0. So I need factors of 105 to add to negative 26, which is going to be negative 21 and negative 5, right? 21 times 5 is 105. So my answer is 5 or 21. So which of these is greater. That satisfies the equation. I plug them in. None of them are going to give me an extraneous solution, so we're good there. So the one that is greater of the two values is 21. Okay, 34. If x equals the cube root of a and 3a equals 24, what is the value of x? Well, I noticed they gave me 3a equals 24. Let's go ahead and divide that by 3 and get a equals 8. And we have x equals the cube root of a. Well, I just found what a is. It's 8. So what is the cube root of 8? It is 2. So x is 2. What's one possible solution to this equation? Solving a rational equation, I'm going to write my LCD, which is x plus 1, x minus 1. And I'm going to multiply every single one of these fractions by that LCD, right? By x plus 1 and x minus 1, with the goal of crossing out my denominators. So in the first one, I'm crossing out x plus 1. I get 24 times x minus 1 minus 12 times x plus 1 equals x plus 1, x minus 1. All right, so I go ahead and distribute 24x minus 24 minus 12x minus 12 equals, and then these are actually the factors from the difference of two squares of x squared minus 1. Oh my goodness, another quadratic trinomial. Let's set it equal to 0. I've got x squared here. Let's do some math here. 24x and negative 12x is 12x. Move it over and you get negative 12x. Negative 24 and negative 12 is negative 36. Move it over by adding 36 and you get 35. So my factors will be x minus 7, x minus 5. All right, because negative 7 times negative 5 is 35. Negative 7 plus negative 5 is negative 12. So my answers are 7 and 5. So it says, what is one possible solution? So 7 or 5. I plug them in. No issues with extraneous solutions, so both will work. So either of them would be an answer. Okay, this is what I talked about with the circle, right? We have the equation of a circle as shown above. What is the diameter of the circle? So I need to make this equation essentially look like that formula that I showed for you before about a circle, okay? Now the way I'm going to do this is I'm going to group the pieces together with x and y, so y squared plus 8y, and then I'm going to complete the square for both of these. If you forgot how to complete the square, that means add b over 2 squared, right, to both sides. So in this case, b is negative 6. Negative 6 divided by 2 is negative 3. When you square that, you get 9. But you got to do it to the other side as well. Then I have y squared plus 8y plus b over 2 squared. It's going to be 16. Add that to the other side as well. So now if I factor this, I get x minus 3 squared plus y plus 4 squared equals, if you add all that together, you get 169. So that's the equation of my circle in this form. All right, but it wants the diameter. All right, remember this form says the radius squared over here. So the radius squared is 169. So that means if I take the square root of both sides, the radius is 13. Doesn't want the radius, it wants the diameter. And the diameter of a circle is 2 times the radius. So my diameter is 2 times 13, which is 26. All right, let's do these last ones. 37. This is calculator still. Based on the graph above, and how many of the games played did the soccer team score goals equal to the median? All right, so 29 games, right? So what I tell students, 29 divided by 2, all right, that's going to be 14 and a half. Now, because this is an odd number, you just round that number, and so we're looking for the 15th data value. So here's 8, put it on top. Here's 8 times that they scored 1 goal, and then 9 times they scored 2 goals. And look at that, 9 plus 8 is 17, so the median is in here. So the median is 2. But we don't want the median. It says, how many of the games did they score 2 goals? And they scored 9 games, they scored 2 goals. So 9 games is the actual answer, 9. Okay, 38. If the mean of the 5 numbers above is 1600, what is the value of x? So you have 700 plus 1200 plus 1600 plus 2000 plus x divided by 5 equals 1600. So let's multiply and do some adding here. So I have 1600 times 5. So I'll use some Desmos since I can use the calculator. 1600 times 5. So 1600 times 5 gives me 8,000. So that's going to be here on the right side. 8,000. I'm going to add this together. Let's see. That's going to be 1900 plus 1600 plus 2000. 1900 plus 1600 plus 2000 equals 5,500. So that's 5,500 plus x on this side. So my answer for x is 8,000 minus 5,500, which is going to be 2,500. All right, so there's my answer for that one. Okay, 39. Oh, this one was pretty tough. I'm probably going to use a lot of room for 39. So it says, in the above equation, what is the value of a plus b if a is equal to 2.5? So they're just trying to mess you up by, if you wrote 2.5, so let me write it again. So if you wrote 2.5 here for a, what most students are going to do is just look at this and think, oh, well, if I look at the top, a plus b equals 5, right? So b is also 2.5. Right? That's not it, though, because if you notice, right, I can actually factor this as x plus 2 and x plus 4. So if I were to kind of isolate b here, I would need to make, right, if I want to get rid of these denominators, I need to multiply by my LCD, which is x plus 2 times x plus 4. So if I do that, I get 5 equals, so this 2.5 needs to multiply by x plus 4. So 2.5x plus 2.5 times 4 is 10. And then plus b times x plus 2. All right, so if I isolate for b, so if I leave this over here, b times x plus 2 equals, if I move the 5, leave the 5, move the 10 with subtraction, you get 5 minus 10, which is negative 5. Move the 2.5x and you get negative 2.5x. And if I factor out negative 2.5, I'll be left with, let me write it this way. I think you'll see it easier. So negative 2.5x minus 5. If I factor out negative 2.5, I'm left with x plus 2. All right, if you look at this, right, if I divide both sides by x plus 2, what happens is the x plus 2's cross out. So b, right, those cross out, is just equal to negative 2.5. So again, most students are going to put positive 2.5, but the answer is actually negative 2.5. All right, we made it, guys. Our last one. Woo! We have this table here. And it says, based on the information given in the table, how much greater in millions was the median number of international tourist arrivals to the top 9 tourist destinations in 2013 than the median in 2012? Okay? Well, what they've done nicely for us is they put it in order. We have 9 data values, so the median is going to be the 5th one, right? If you start, you can do it like you did in algebra, where you go 1, boom, boom, boom. Boom, 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 boom. In middle school, so you would see that these are the medians because they listed them in order from least to greatest. So what's the difference in that? How many more or how much greater in millions was it in 2013 than 2012? If you subtract 47.7 minus 46.4, you get 1.3 million. All right. Now, you would have to bubble that into the SAT, so you just bubble in 1.3. You can't bubble in the million part. All right, guys, I know that was a long video. I get it. Lots to do there. But hopefully, this will help you give you an idea of what to expect for the final. Good luck.